In this problem, we're asked to integrate improper integral. That is an integral that has infinity as one of its limits of integration. And technically, this is called a type 1 improper integral. There'll also be a type 2 improper integral that we'll look at later. So we're integrating from 0 to infinity the function 2x over the quantity x squared plus 1 raised to the power 4. And the first thing that I recognize from this problem is that it is a method of substitution scenario because the derivative of x squared plus 1 is 2x. And so we'll be able to let u be x squared plus 1 and solve the problem that way. So if I let u be x squared plus 1, then of course du is going to be 2x dx. And fortunately, that is exactly what the numerator is, so that will simplify nicely. But also, since there are limits of integration, when we do our substitution, we need to change those limits of integration. The upper limit is infinity. And when x is equal to infinity, we need to figure out what that would correspond to with u. But u is x squared plus 1. And if you take the limit as x goes to infinity of x squared plus 1, you still get infinity. So the upper limit actually just remains infinity. However, that's not always the case. Sometimes it will change. The lower limit in this problem does change. When x is 0, if I plug that into the formula for u, I get 0 squared plus 1. And so u is equal to 1 when x is equal to 0. Now that we have the new limits of integration and the two formulas that we need for our substitution, we can actually make the substitution. So the lower limit of integration changed to 1. The numerator is exactly du. And x squared plus 1, that was u, and it's being raised to the power 4. The next thing that I want to focus on is the thing that's actually making it an improper integral, the fact that we have an infinity as the upper limit of integration. And the way we deal with that is we're going to replace it with a placeholder variable, a parameter that we'll call b. Now we just have a regular definite integral. We can evaluate this definite integral, and later we'll end up taking the limit as b goes to infinity to recover the original problem. So next, I'm going to integrate this 1 over u to the power 4 by thinking of that as u to the power negative 4, just using the laws of exponents. Now I use the power law for integrals. I'll increase the power by 1, divide by the new power, and after simplifying, we end up with negative 1 over 3 times x cubed. Because you end up with x to the negative 3 power over negative 3, and then you just rearrange it to get this. We need to evaluate this from 1 to b. So as usual, we just do the top minus bottom. Plug in the b minus what I get when I plug in the 1. When I plug in the 1 of minus minus, turning into this plus. Now I need to actually go back and address the fact that we have this integral where the upper limit is b. However, we need to make that b turn into infinity, and the way we do that is by applying a limit. So we're going to take the same result that we just found, but we're going to take the limit as b goes to infinity. As usual, you can do limits term by term. And the limit of the first term, the limit of 1 over 3 b to the power 3 is going to be 0. Because as the denominator gets huge, the entire fraction goes to 0. And the limit of a constant is just equal to that constant, so the 1/3 remains. And adding these together, we get the final result, which is 1/3. So this was an example of an improper integral of type 1, where we also had to use the method of substitution. You can also see variations of this problem where instead of having infinity at the top, you have instead negative infinity as the lower limit of integration. And you do it pretty much the same way, except you would use, you would make the negative infinity turn into some other variable like a, and then you would do a limit as a goes to negative infinity.